In this video, we're going to look at our test review over differentiation rules. Starting here with question number 1, we're asked to find the slope of the line tangent to the graph of y equals 5 over the square root of x squared plus 9 at x equals 4. So this phrase right here in the question, slope of the line tangent, that is just another way of asking us to find the derivative. Remember that the derivative is the slope of the tangent line. So we need to find the derivative of this function. And when I look at that function, I'm going to ask myself about what derivative rules we need to use. Is this the power, product, quotient, or chain? I see that there is some division, and we might think quotient rule, but in the numerator here, notice that we just have a constant. And since there's no x there in the numerator, that's an indicator that I can rewrite this function y as 5 times the x squared plus 9. And since that's in the denominator, I'm going to give it a negative power. And since it's under the square root, we're going to make it to the negative 1/2. So I've just rewritten the denominator there with a negative exponent. Now in this form, hopefully you can see that all we need to do is employ the chain rule. I have 2 layers to this chain rule. I have the negative 1/2 power on the outside, x squared plus 9 on the inside. So I'm going to set up the chain rule chart, and we have 5 times something to the negative 1/2, and then that something is x squared plus 9. When I do my derivative on the first layer of this function, I'm going to multiply negative 1/2 times 5. And so we get negative 5/2 times something. And then for the new exponent, we're going to do negative 1/2 minus 1. Or negative 1/2 minus 2/2 would be negative 3/2. And the second layer, that derivative is 2x. Now remember, this goes back inside on the chain rule. So we have negative 5/2 times x squared plus 9 to the negative 3/2 times 2x. So this is our derivative function, but remember in the problem we were asked to find the derivative at x equals 4. And so we're going to need to plug 4 into this derivative function and get a numerical value. Now whenever we have negative exponents or fraction exponents, both of which we have here in the same exponent, it's going to be helpful to take the time to rewrite that before you substitute a number in. It's just going to make the arithmetic a little bit easier. So I'm going to rewrite this as negative 5/2, and actually let me start over. Since we have a negative exponent there, that means we're definitely going to have a fraction, because that negative exponent is going to put x squared plus 9 in the denominator. So I'm going to start my fraction. I've got negative 5/2. So I'm going to put that negative 5 on the top and the 2 on the bottom. The x squared plus 9 has a negative exponent, so it's going to go to the denominator. That exponent is a fraction, and so the fraction means a root, and this is a square root, in fact. And then the numerator is the 3, and so that means that this is going to be cubed. Then we still have that 2x out there. It does not have a negative exponent, so it's going to stay right there on the top. Now I think this is in a version where we can plug in 4 and work on getting an answer. So at x equals 4, let's see what we get here. Negative 5 times 2 times 4 over 2 times the square root of 4 squared plus 9 cubed. And so on the top, if I multiply those things out, we're going to get, let's see, negative 5 times 2 times 4, that would be negative 40. On the bottom, I have 2 times the square root of 25 cubed. Now, some of you may look at that and think, wow, I don't know what 25 cubed is. But since the cubed and the square root are both kind of on the same level in the order of operations, because they're both exponents, that means I can square root first. And so I'm going to change this to negative 40 over 2 times the square root of 25 is 5. So I can make that 5 cubed. And now that's a little bit easier arithmetic to do. So we have negative 40 over 2 times 125. And that is negative 40 over 250, which finally reduces to negative 4 over 25. And so we get answer A. All right, let's move on to question number 2. Here in this question, just as if y equals tangent x minus cotangent x, then dy dx equals what? So we're asked to find the derivative here. And this is just a straight use of our trig functions. So dy dx, I mean our trig function derivative rules. So dy dx is going to be the derivative of tangent x, which is secant squared x, minus the derivative of cotangent x, which is negative cosecant squared x, and that's our derivative. I do have minus a negative here in the middle, so I can turn that into a plus, and I end up with secant squared x plus cosecant squared x, answer A. All right, moving on to number 3. Evaluate f prime of negative 1, where f of x is equal to this function. Sorry, I forgot to get the pen. Here we're back. So when we look at that, we want to ask ourselves, okay, what derivative rule do I need to use? This power, product, quotient, or chain? And we need to be careful in making that choice because it looks like maybe this is a product rule. Maybe you're seeing it as a quotient rule. But this 1/3 that's here in front, that is just a constant. And whenever we have a constant multiplier, remember that that can just stay there, and we're going to do the derivative of whatever comes after. And so this one is actually just a power rule derivative. F prime is going to be equal to 1/3 times, I'm just going to keep that constant multiplier there, and then I'm going to do the derivative here. The derivative of x cubed is 3x squared, and minus the derivative of x to the negative 3, so that negative 3 is going to come to the front, which would make this plus 3x, and then negative 3 minus 1 would be negative 4. Now again, we're asked to evaluate this derivative at a particular value at negative 1. And so before I do that, since I have a negative exponent, I'm going to rewrite it because remember that's going to make our arithmetic a little bit easier when we substitute in. So I'm going to rewrite this as 3 over x to the 4th. And now I'm ready to sub in. F prime of negative 1 is equal to 1/3 times 3 times negative 1 squared plus 3 over negative 1 to the 4th, which is 1/3 times negative 1 squared, of course, is just 1, and negative 1 to the 4th is also 1. So I just end up with 3 plus 3 there on the inside, which is 6 divided by 3, gives me an answer of 2. Let's do one more on this video. Question number 4. What is the equation of the line tangent to the graph of this function? Now when we look at that function, you can ask yourself, what derivative rules do I need to use? Is this power, product, quotient, or chain? I don't see a product rule. I don't see quotient. I don't even see a chain rule. A little power rule there on the end, and then we're going to use our exponential rule for 3 times e to the x. So let's start by finding f prime. Remember that the derivative of e to the x is just e to the x. We have that constant multiplier of 3, so we're just going to keep that. 3 times e to the x. Derivative of minus 2x is minus 2, and the derivative of 4 is, of course, 0. So there's our derivative. We're asked to find the equation of the tangent line at the point 0, 7. Now remember, to find the equation of a tangent line, we need to know 3 things. We need to know what a is equal to, we need f of a, and we need f prime of a. We want our tangent line at the point 0, 7. That tells me that my a value is 0, And since they gave us both coordinates of the point, then I know f of a is 7. So all I need to do is figure out f prime of a, which would be f prime of 0. So I'm going to come over here to my derivative. F prime of 0 is 3 times e to the 0 minus 2, which is 3 times 1. E to the 0 is 1, minus 2. And 3 minus 2 equals 1. So f prime of a is 1, and I have everything that I need to write the equation of the tangent line. My formula, y equals f of a plus f prime of a times x minus a. So y equals f of a, which is 7, plus f prime of a, which is 1, times x minus a, which is 0. And so y equals 7 plus 1x, or just 7 plus x, which gives us answer E.